Hi guys, this is Said Jawad coming back again with a new video. This time we're gonna try to use functional programming to reduce code complexity. The agenda, what we have covered already in the previous times, and then we'll go ahead with reducing the complexity with the functional programming live demo. What we have already covered in the previous videos is refactoring tools and strategies using displacement by responsibility. We did also some abstraction using polymorphism and built-in functionality. Functional programming is built-in functionality in Java, so it might fall in that category, but I would like to highlight it separately because it is in its own right a different way of thinking and programming, and needs its own attention to get its usefulness. I did get some feedback about the previous videos, which I am very grateful for, and I'm going to try to make the video a bit shorter, so it wouldn't be a drag watching it. Yeah, let's start. Let's go. The functional programming example I have put on the screen on my GitHub account. You can download it and try it out yourself and do the exercise. And yeah, I'm going to switch to the code. I created a small class with a bit of high complexity that I would like to use to explain how to use functional programming to reduce the code complexity. In this case, it is a class that does one thing. It is a class that does a validity check on an array of social security numbers as they are used in Holland, and these social security numbers are checked for validity by doing an 11 proof. So an 11 proof is a method that you can, I will post a link on Wikipedia on how it is done. It takes a number of multipliers and it multiplies it based on the position of the social security number. First number with the first one, the second with the second, all the way to the last number, and then sums it up. It adds up all the multiplication results to get a total, and the total is being modulus 5, so divided by 11 shouldn't give you a valid number, shouldn't give you any numbers behind the comma, should be divisible by 11. If not, it is not a valid 11 proof number. What this program does is does some validity checks on the arguments being entered, and then splits the argument 0 into an array of numbers to be checked using a comma as a separator, and then if it does some more checks that there are actually numbers being entered, and it creates an array list to store all the new results in them, and the results being a message instead of a valid or invalid number. It's a message about a valid or invalid number. As you can see, there are some if statements, and there are some for loops inside which create the complexity. So let's start by making them a bit less complex. If you have worked with functional programmers, then you are familiar with predicates, which are what we are going to use. So we're going to use predicates for the validity checks, and functions for the transformation. Yeah, start by the first one. So the first one does check on the incoming string array, and it checks if it is not null, and it also checks afterwards if the length is greater of the array elements is greater than 0. It moves on to check that the first element is not null and that it has the length, the first element, which is a string, has a length greater than 0. So start by the first predicate, which is this one. Let's see if I can just extract it. It does kind of, but it's not the predicate as I would like it. I would like to really use the functional interfaces that are provided by Java. So for now, let's say it is array is not null, but instead of this way, I would like to say predicate, which is the interface for the predicates that are being used in the streams in Java or in Java in general. T would be a string array, and let's say array, and here array is not null. So this is our first predicate, and we'll use it. It will provide, this interface will provide a method test to check your array, in this case, string array, if it does, if it returns a boolean that is true or false. So we'll put the args here. This is the first predicate. Second predicate, also this predicate is not going to change, so we might as well make it into a constant and put it outside. So this is the first predicate. Second predicate is this one. Let's extract it as well. Array length greater than 0. All right. So this one is also a predicate. Also uses a string array as input and does the same as the other one. So as far as naming goes, so array is arrow, and then the array length is greater than. Let's make it into a constant as well, and then do a test, and then args, takes args as well. Well, we have done this. Nice. So we have the second, third and fourth predicates. Do the same thing there. So first element is not null, and predicate, this one takes a string, and we'll do this. It does get an array, so it's an array, arrow, then array is not null. Did I do it right? Why is it saying that I'm doing array type expected found Java string? Okay, forgot to do that. Make it into a constant, right, and then dot test, args. Okay. One more predicate is the length of the string in the first element. So let's do that. String length, no, first element string length. Right. So keep it like that. Predicate takes an argument, takes a string array as argument, and then array right and array here. So make it into a constant and do the same test again. Test args. So we have created some readable tests, predicates that we might use later on. So we have passed all the validation steps here in the first place, and going for the next one. In this here we are going to split the numbers, and then if the numbers array length is greater than 0. Now here's the thing. So this numbers array length and this check is greater. This is a string array. I could just use this previously made array is greater than 0 length and replace predicate and use it here. So we can say this one and then test, and length is greater than 0, and without the length and without the 0, and voila, we have already done our first decreasing of the duplication in code. And then we go inside the loops and see what they have there. Do we have any more ifs and validations? I do not believe so. Oh, we have one. We have one. So we have this, right? So we are checking for the modulo 11 check, which returns a boolean. This we can do as well. We're going to modulo 11 check. Let's say it's a predicate that takes a, let's see, this predicate takes an integer, and this integer will take the sum, no, well, let's say the sum or the number. We'll call it the number. And it's also a bad name because we already used the number. Total. Oh no, it's actually I'm making it more hard for myself to think of a number because I already used this number sum. So modulo check number, and then the modulo check number. Yeah, this should do it. And yeah, should do it. So the test sum. All right. So we did this. We can inline it Let's see if I can inline it. Yeah, inline it. Oh, do I use it on more than one place? No, I shouldn't be using it. Anyhow, this predicate I can also make a constant because this doesn't really change. The good thing about predicates and functions is when you write an if statement, this if statement is there in the class and you cannot use it anywhere else. You cannot extract it, you can put it, yeah, well, you can extract it and put it somewhere else, but then still it is not a common interface that you can delegate to a stream of functional programming built-in Java functionality. So the benefit of the predicates and the functional function interfaces that you use in functional programming is that you can reuse them and put them somewhere else and test them separately as well. And they are less rigid. So the complexity didn't go down. You have already noticed this. You should have noticed it. Now we're gonna, because we didn't really change the code, we just have written it now a bit differently. Now let's go ahead and do, we have prepared the predicates. Now we can do one more thing, which is actually this. We are taking a number, doing some transformation to it, and then creating a message. That's mapping. We can create, let's extract a method first, get validity message, and this function will take in a string number and return a string message. We can actually extract this into a function, a class. I'm gonna just make a package called mapper and create a new Java class called number to validity message. This implements a function interface that you gets a string in and gets a string out. All right, so implement the method, right, with an apply, and then we are going to take this whole shebang let's see if I'm doing it right. We'll call this number, and we miss a few things. So we need the BSN number length, the multiplier array, and the modulo check. And we can get all of these here. So let's see if I'm doing this right. Yes, I think I am. These are the statics we need. We don't need them here anymore, right? And this whole function is no longer necessary because we're going to say here let's create a number to validity message, number mapper is new, right? So var copy and then dot apply. This will do the same thing. So we have created one function, and now there is one more transformation, but that would be a bit of an overkill because this does the job just fine. I could change this also into a functional interface, but let's leave it for what it is right now. Okay, now we have done a few things, and I can see that I am doing one thing that I should do. Inside the if statement. That's more clean. All right, now we're going to change this function, this whole program, into a functional string. So what are we doing? We are going to take the arguments, check if it is not null, and if it is not 0. Now I'm not sure if I need if it is not 0, just that it is not null. That would be a good start. So I'm gonna do the first check. And inside this, if it is not null, then I can change it into a string. After checking the first element's validity. So if it is not null, then I would say arrays dot, going to change the array into a, first we need to split it. I'm going to do the same thing here really. So I'm splitting it here. We have a numbers array, and then we're going to loop over the array, or stream the array, better put actually, arrays dot stream numbers array. So now we have a stream, and what do we do with this stream? We're gonna loop through it. So we're gonna stream it, we're gonna loop through it, and then loop through it and check its validity. See, when you have an array and you have no, we need to do a few more things. So the array length is greater than 0. That is, I'm not sure if that's important. We will need to know if it does have any elements, so we'll have this check actually. So if we have this, and then we know that there is something inside. Now we don't know if it is valid or not, but that's what we're going to check. So we have already created the stream of the split numbers within the at least one element that is inside. So we have a number array hopefully greater than 0. We're going to do a map operation using the validity, using the mapper, which is a function, and that's, let's see, mapper, map. I need to create a mapper here as well. So we're going to map them. Then we are going to log the results. So for each, I'm going to get the message out, have a message, and we're going to log that message. And shorthand replacement, this is what we're going to do. Now I think we can remove this. And we no longer need those, because when we're mapping through the elements of this of the arrays, is going to, if there's nothing, then there is nothing to loop over. Yeah, let's make this with a suggestion from IntelliJ. Okay, so now it is shorter. It should do the same thing as we have done before, and I can make these as well a bit, I can even make it a bit better, but for now I'm gonna leave it. Let's see what it does, if it's still working really. So we have a few tests. Let's see if the validity messages are working correctly. Let's see if multiple valid BSNs is working, or multiple invalid ones is working. Let's run the tests. Fingers crossed. It's working. Nice. All right. So it's as you have seen, it is a few things. It is using internal functionality built in Java and provided by functional programming interfaces like functions and predicates. And it's a bit of a different way of thinking and letting telling. It's also telling the program what you want instead of how you want it to be done. Instead of if else and change, please stream, map, and for each, and then use the internal workings of the interfaces that are provided. Now it is also a bit of displacement, because we have displaced some of our functions and predicates elsewhere, which also helped shorten it. I realize now I might also need to give a bit more explanation, maybe on the subject of functional programming as a separate thing, instead of also using it to show you that you can lower the, in this case, the cognitive complexity, which is what we have done. The less things that you, the less checks and predicates you have on one line, and going through it like step by step, is the more readable your code becomes. But we also did a bit of displacement, and there is more to be done inside these classes, and I could also extract the predicates into separate classes as well. But for now, this is actually enough. I think I'm going to do a special segment specifically and only for how predicates work, although I've shown you how they work now, but a bit more elaborate, and how you can loop over them and over functions. For now, I hope this video has been helpful, and yeah, I download the code, play with it around a bit, and please give me feedback if you need a bit more explanation, or you can help me improve how I explain things if they are not too clearly explained. So please, any feedback or likes are always welcome, and hopefully till the next video.